In today's video, we are going to do some theorems on circles. Theorems, we're just going to go through the statements and the meanings of the statements, the enunciations actually. So we are going to go through 9 such statements, okay? Theorems on circles. Now before we begin, let's go through one thing, which is, suppose there is a point, okay? How many circles can we draw through this point? Let me make a, we can't see this one. Suppose there is a point, so how many circles can we draw, or how many circles can we make pass through this point? 1, 2, 3, 4, 5, 6. So how many? Infinite number of circles, okay? So through one point, infinite number of circles can pass. Now suppose I have 2 points. Now how many circles can pass through these 2 points? We can have one circle like this, one like this, one like this. So how many circles now? We can have infinite number of circles passing through these 2 points. Okay? So, how many circles can pass through 3 points which are collinear? Can you draw any such circle which will pass through 3 collinear points? Is it possible? I can't. Can you? I don't think you can. So let's try 3 non-collinear points. How many circles can you draw? If you try, you will see that you can draw only one circle. So this is where we come to the first theorem of the 9 theorems that I was talking about. So the first theorem is only one circle can be drawn through 3 non-collinear points. Okay? So our first theorem today is only one circle can be drawn through 3 non-collinear points. Number 1, 3 non-collinear points. Only one circle can be drawn through these 3 non-collinear points. Alright. So now let's go to the second one. The second theorem is, in a circle, there is a chord. This is a chord. If a straight line is drawn from the center of the circle to the chord perpendicular to it, then it bisects the chord. Let me repeat. If a straight line is drawn from the center of a circle to a chord perpendicular to it, then it bisects the chord. Okay? This is broken up into halves. Alright? So what will be the converse of this theorem? Converse means given of this theorem becomes RTP of this one, and RTP of this theorem becomes the given of this one. So suppose there is a chord, there is a center. If a straight line is drawn from the center to a chord to bisect it, then it is perpendicular to the chord. So these 2 theorems are converse theorems. Okay. Now we go to the fourth one. The fourth one says, in a circle, the angle at the center, this is the center, this one is the angle at the center, this is double that at the circumference. Okay. So if this angle is 2x degrees, then how much will this angle be? This angle will be x degrees. Okay. So I'm repeating it. The angle at the center of a circle is double that at the circumference. But what is most important is subtended by the same arc. Okay. So I'm repeating it. The fourth one is, the angle at the center of a circle is double that at the circumference subtended by the same arc. Number 5 is, in a circle, if I draw a chord, then this becomes a segment, the major segment, and this part is the minor segment. The fifth theorem tells me all the angles in the same segment are equal. So this is one segment. Let me draw as many angles as I can in this segment. So here is one, here is another one, here is another one. So I am able to draw 3 angles here. All the values will be same. So if this is x degrees, this will be x degrees, this will also be x degrees. Why? Because all the angles in the same segment are equal. Okay. So what about the 6th one? The 6th one again is the converse of the 5th one. So these two were converse theorems. Now the 5th and the 6th again will be converse theorems. So what will be the 6th one? The 6th one says, if a straight line joining 2 points, a straight line is joining them, I'm repeating it. If a straight line joining 2 points subtends equal angles at 2 other points, subtends equal angles at 2 other points. So if this is x degrees, this one is also x degrees, then the 4 points are concyclic. That is, a circle can be drawn through these 4 points. My circle looks horrible, but the theorem tells me if a straight line is drawn, if a straight line joining 2 points subtends equal angles at 2 other points, then the 4 points are concyclic. So these 2 theorems are converse theorems. Now what about the 7th one? The 7th one says, in a semicircle, we draw a circle, we draw the diameter. So this becomes the 2 semicircles, okay, with the help of the diameter. Any angle, I draw any angle in the semicircle. This is a right angle. So what is the theorem? Any angle in a semicircle is a right angle. That is the theorem. Okay. Now, can you relate to a construction that you have done in your earlier classes which relates to this theorem? Remember constructing a right angled theorem, right angled triangle, without drawing 90 degrees? That is drawn according to this theorem. You used to draw a semicircle and then a right angle. Any angle inside it used to become a 90 degree because of this theorem.